Hey guys, welcome back to the channel Techbeast.org. So today I have come up with something interesting, which is more like a sequel of my previous videos on Kafka. Okay, so I hope you guys enjoyed the videos on Kafka, which we have made two videos on part one and part two, where we have explained all the basics and theoretical portions of Kafka and the key components which is making Kafka functional. Okay, and also in part two we have did some hands-on. Okay, so where we have published some simulated temperature data and how Kafka is handling we have seen. Okay, so this topic is very important for if someone is looking into data science or getting their career into data engineering. Okay, or more into real-time streaming. Okay, or if you are an enthusiast and you are wondering like, hey, how all the millions of sensor data are being processed in today's scenario. Okay, so we are talking about millions and billions of devices nowadays. So how all these real-time data is being streamed, and how all these real-time data is being processed. Okay, so this is something very interesting topic which we are going to see today, and with hands-on. Okay, so that's what it's so special about our channel. Okay, so we are going to do hands-on. We are going to set up our own real-time streaming setup using Confluent, which is more like a Kafka as a service, a cloud-based Kafka service provider, and we are going to use Databricks, okay, which is more like a cloud platform for Apache Spark, okay, so which we have explained a little bit on my previous video. So if you guys have missed it, I strongly recommend you guys please go and watch that first, and please come to this hands-on session. Okay, so let's get into the topic. So before we talk about real-time streaming and real-time processing, we need to understand Apache Spark. Okay, so because we are going to use this open source tool. Okay, so in this particular video, so basically, what is Apache Spark? Before we understand Apache Spark, we need to know Hadoop. I think most of the people who are working in big data would have come across this word Hadoop. Hadoop MapReduce. It's a programming model. Okay, for processing big data sets with parallel and distributed algorithm. Okay, so since it is a sequential process, MapReduce jobs are slower due to disk IO operations, input output operations. Okay, so basically the data will be read from the HDFS file system, then the data will be processed, and then the data will be written to the HDFS. Okay, so this is more like intensive. Okay, so it's like more process, more resource intensive tasks, and that's why it's slower due to the disk IO operations. So in order to bridge this gap, Spark was created to address this limitation to MapReduce. Okay, so by doing process in memory, so basically all your data will be loaded into the memory, and your tasks are being done, okay, but based on your logics. Okay, so this basically reduces the number of steps in a job, okay, and by reusing the data across multiple parallel operations. Okay, so now you know why Apache Spark is really playing a major role in today's data processing. Okay, so the good thing is, of course, we talk more about open source, and of course, Apache Spark is an open source software. Okay, it's a distributed processing system, especially used for big data workloads. Okay, so what is Confluent first? Okay, so we have seen a lot of things about Kafka. Okay, so we have set up our own Kafka cluster in your own laptop. Okay, and we have able to create a topics. We published some telemetry messages over the topics, and we have consumed it. Okay, so what is basically Confluent? Okay, Confluent is basically a cloud-based data streaming platform which is using Kafka. So in simple words, you can take it as a Kafka as a service. Okay. Okay, so then it's basically founded by creators of Kafka. Okay, so that's why it's a one of the popular data streaming platform in the market today. And Kafka as a service with improved performance, as I said. Okay, the advantage between deploying your own Kafka cluster and managing it under Confluent is basically the Confluent will take care of your entire Kafka cluster, so you don't need to worry much about the operations and maintenance of your servers and all those process. Okay, so this really helps you to reduce a lot of cost. Of course, it's not a free service, but Confluent has provided some trial versions and giving some $400 credits. Okay, so basically for you to try and learn Kafka from the cloud perspective, and we are going to use that today. Okay, so we are going to utilize that functionality, and we are going to create our own Confluent cluster, Kafka cluster in the cloud. Okay, and we are going to publish the data. Okay, we are going to produce the data and send it over to the Confluent real-time streaming platform. Okay, then we are going to use Databricks to process it and store it in a database. Okay, so now let's talk about Databricks. Okay, so basically Databricks is created by creators of Spark. Okay, Confluent was created by founders of Kafka, and Databricks was created by the creators of Spark. Okay, nice, right? So it provides an interactive web-based platform to work with Apache Spark. Okay, so you can easily manage your Spark clusters and workloads in a notebook like IPython Jupyter Notebook. Okay, if you're ever used Jupyter Notebook, you guys may be already aware of it. Okay, so basically it's a notebook where you can execute your Python queries and run and verify step by step. Okay, so not like a typical programming, like run everything in one shot. You can verify each single steps and see how your programming is running through the notebook. So I'll show you later how it looks like. Okay, so then Databricks manages updates of open source integrations in the Databricks runtime releases. Okay, so basically in Databricks we will choose a runtime. Okay, so which runtime you're going to use to run your Spark applications and your notebook and your workloads. Okay, so then it provides services via popular cloud services like AWS, Azure, and GCP. Okay, so you can choose the cloud providers whomever you want, and you can able to create a Databricks service if you are using for an enterprise application. And of course, for enthusiasts, Databricks provides a community cluster, and which we are going to use it today. Okay, so let's see our setup today. Basically, this is our setup, guys. I have given the GitHub code in the description. Please do check it out. Okay, and you can refer the code which is being used for this hands-on. Okay, so we have the IoT simulator here. Okay, so where we are going to simulate a temperature sensor data. Basically, it's the same set of code we are going what we used in our previous video for Kafka. I'm going to use the same code, but instead I'm going to send it to the Confluent cloud. Okay, rather than produce it to my own Kafka cluster. So then we are going to create an account in the Confluent, and we will create a cluster, okay, in the Confluent. So basically, this is our real-time streaming platform. So then the data from the Confluent will be sent to Databricks. So basically, Databricks will read the data from the Confluent in real time, and we will do a data aggregation. Okay, so basically, the business logic can be anything based on your use case. Okay, so you can do anything. Based on your real-time processing applications. Okay, so in my case, I have just taken a simple data aggregation logic. So all the real-time streaming data, which is coming like every seconds or 2 seconds or 5 seconds, you can able to aggregate it to according to your need, like 1 minute, 2 minutes, 5 minutes, 10 minutes accordingly. Then you can store it in a SQL database. Okay, so overall, this is our setup, which we are going to do today. So let's set up our Confluent cloud account first. Okay, so log into confluent.cloud and just sign up with your username and create an account in confluent.cloud. Okay, so then what you're going to do is so basically you can these are the steps. Since I have already created it, I just took a screenshot for you guys to show how it basically looks like. So the first step is basically you need to create a cluster. Okay, so you can just choose the basic cluster, which is basically free. Okay, so you can see the specifications you have been offered, and your uptime SLA is 99.5%, which is good enough for us. Okay, so then as a next step, you need to choose your regions and zones. Okay, so basically which cloud provider you're going to use. You will be asked whether it's AWS or GCP or Azure. You can basically choose whichever the service you want. So then you can just set up your payment method or give your card details, unless you'll be given a $400 credit at first. Okay, and unless you don't overuse it, okay, you won't be charged. Okay, so basically this is basically a demo setup, and which is really good for us to learn how Kafka in cloud is being used and how efficient it is. Okay, so once you fill up your name, so in my case, I have just used the default settings for the cluster, and I have used the default name. Okay, then you can just click the launch cluster. Okay, so once you launch the cluster, you'll be able to see you'll be able to see a platform like this, and you can see your cluster status, which is running now. Okay, so you can see your throughputs, how much is your consumptions, and all those details basically. So then so here I have already created a topic. So but before you do, so what you need to do is just go to topics. Okay, so then you can just click add topic, and you can just give your topic name. So in my case, I have just used the default settings, and since I have already created, my topic is already topic_0. Okay, so in your case, just create it. with your default settings. Okay, so then you can see all the messages, how much is how much messages are produced, how much is consumed. Okay, so when Kafka data is being when Kafka data is being published here, you can see your real-time messages here, and you can see the retention time is basically 1 week. Okay, so in my case, I have already published a few messages, so that's why you are seeing it here. Okay, so this is basically the initial setup for Confluent Cloud. Okay, so once you set up the cluster and set up the topic 0, you're good to go. Okay, so then there is one more step, guys, we need to take note of it. Just go to clients, so you can just set up a new client. So in my case, I'm gonna use Python. Okay, so let's just click Python, and you'll see a sample client.properties here. Okay, so basically you can just create a Kafka cluster API key, and you can create a this will create a API key and an API secret. Okay, so basically, so all you need to do is just once you create it, this will automatically populated with your API keys and secret. So all you need is just copy and store it in a client.properties file. Okay, so in the folder where you're going to execute your producer. So then these are all you can create a virtual environment. So this is basically the basics of Python. So just run the pip install confluent.kafka, and we also need config parser. Okay, so in order to parse all these configurations, okay, given in the client properties. So then this is the code for producing the data. So basically I have used this to read the configuration and establish a connection with the Confluent, but our actual code is here. Okay, so in my case, you can see the Kafka IoT Confluent producer. So you can check the code in the description. Okay, so I have stored all the client.properties. I have excluded it in my gitignore, but in your case, you should have a client.properties. Okay, since it contains the API key and secret, I did not include it here. Okay, so basically it's included in this client.properties file. Okay, so you can see we are simulating a temperature sensor here. Okay, so basically we are this function basically reads the client.properties, okay, of all these username, credentials, and all those details from the Confluent Cloud. So then this function basically publish the data to the broker. Okay, so I will show it to you guys once we once I show you on all the entire setup process, then we can execute the code and see how. Okay, so then okay, so this is basically the code we are going to use. So once you have finished all this setup, your Kafka cluster on the cloud, okay, is ready. Okay, so then you can able to use this cluster for producing the Kafka messages. Okay, so basically this is your cluster's domain name. Okay, so you can see here, this is the Kafka cluster which is running on AWS, and the port number is 909. Okay, so via this you can able to connect with your Kafka cluster. So next, let's set up the Databricks account. Okay, so all you need to do is just go to community.cloud.databricks.com. Okay, you can sign up with your username, password. Okay, so you'll be given a free 15 GB memory cluster. Okay, so basically, because clusters, of course, it's very much expensive, right? So but of course Databricks is giving something for the community to try out and really experience the power of data processing and real-time processing. Okay, so basically what you can do is you can just create a new compute. Okay, just give any compute name. In my case, I have given Techbeast cluster 01. Okay, so you can choose, I have just chose the default runtime. Okay, then you can basically in your environment variables, what you need to do is so you can see in our Databricks code, we have used all these environment variables. So this is my Postgres database as username, my database as password, my database as IP address. Okay, so then of course my username and password for the Confluent connector. Okay, so basically all these details you need to pass it in your environment variable here. Okay, so just fill it in like pg username is equal to whatever it is. Okay, so then once you fill in the details, you can just create the compute. Since I have already created one, I'm not able to create a new one, because for community edition there will be only one cluster which you can create and use it. Okay, so in my case I have already used it. Okay, so this is my cluster, Techbeast cluster 01. Okay, so So then what you need to do is basically you can explore a lot of options here, menus here. So in my case, I'm gonna just go to the workspace. Okay, so basically you can create a folder just for you to manage your Databricks codes. Okay, so in my case, I have created a Techbeast dash code folder, and inside my code, I have created a Scala programming notebook, which is like IoT real-time streaming. Okay, so all you need to do is just click it and create a notebook. In my case, I have already created a notebook. Okay, so basically we are going to use Scala. Okay, so the reason I'm using Scala is a native programming language for Apache Spark, which has a direct interaction with the memory. Okay, so if you use Python, so basically we call it PySpark. So it's a little bit time consuming and more less efficient comparing with Scala. Okay, so because Scala is a native language, so hence it runs efficiently for larger workloads. So here we are importing all our required functions. Okay, so here I am defining all my environment variables in a variable. Okay, so here I am defining the connection properties for my SQL database. Okay, so this is my username and password for the which is basically the which is basically my the cluster. When you create a client, so basically you would have noticed this one. Basically, you have noticed the API key and API secret. Okay, so that's the username and password here, and this is my Bootstrap server. Okay, so which you can see already here in the Confluent Cloud. Okay, so this is your Bootstrap server to connect to the Kafka. Okay, so here I have defined some of the security mechanisms, and we have passed the API key and secret, and I have mentioned my topic here. Okay, so to read the data from. So you can change it according to your topic name. Okay, so then here the starting offset, so which is basically the functionality of Kafka. You can either read the data from the beginning, or you can read the data um, from the latest data, for example real-time data alone. Okay, so then you can always specify which offset you want to read the data from. Okay, such functionalities Kafka we can able to do it. So in my case I have just mentioned earliest. Okay, so it will read basically all the data which is stored in the Kafka broker already. Okay, so if you change it to latest, this will only read the real-time streaming data. Okay, so in my case I've just chosen it as earliest. Okay, so then you can load it. Okay, so basically once you execute the code, once you execute the run cell, it will, you see, the command will be connected, sent to executed in the cluster, the Spark cluster, and you can see it's already completed. So basically these are all the Kafka data which you can see: key, value, topic, partition, offset, timestamp. Okay, so then once you just scroll down, just for the sake of your understanding, guys, I have just split it into two separate sections. So on top we are loading the data, and in the below code we will just do the aggregation logic. Okay, so basically this is our aggregation logic. So here I'm defining a schema for my payload. Basically in my payload it's a simple JSON payload which is having a key with temperature and value. That's it. Okay, so here I'm just defining all the doing some data massaging. So basically I'm reading the Kafka timestamp. Okay, I'm casting it as timestamp, and the naming I'm using it as the same timestamp name. Okay, so in my case the key I'm casting it as string type. So you can see the keys in the messages, which is basically my you see the room, whether it's hall or kitchen or bedroom, whatever it is. So I have used it as a key, okay, to segregate. Then my value is the temperature value. Okay, just a simple JSON payload. Okay, so then of course we are grouping it. We are grouping the in order to perform aggregation, you need to have a grouping column, right? So in my case, I'm taking the room column as a grouping column, and I'm grouping the data to every 1 minute. Okay, so you can set however you want, whether 20 seconds or 5 minutes, 10 minutes, 1 hour, according to your logic. Okay, so then we create a new column called average temperature. Okay, which will show the average temperature. So then basically when you do select, it will just display the value for that particular data frame. So let's try it out. Okay, so so here I'm displaying the tumbling window with 1 minute, and by reading all the data um, in the Kafka broker. Okay, so we have executed the command. The command will run on the cluster. Okay, so basically all the distributed parallel processing will be happening here, and you can see here the stream has been initialized. Okay, so you can see the Spark job has been started. Okay, so let's just wait for a while until it shows. So you can see the data coming from the value, It's basically timestamp, room temperature, then tumbling window has timestamp, room, and average temperature. Okay, so let's just wait for a while. So you can see the data frame. So we can see the process is being started, and the process is being executed in the Kafka cluster. So you can see the raw data, so you can see the batch ID, and how these are all the native functionalities of the Kafka. So you can see here all the data has been aggregated to 1 minute. You can see, so 9.6 hall, it's 27.79, it's the average value. Then 9.7, then let's arrange it in ascending order. So you can see, so 9.6 for hall, 9.6 for kitchen, 9.6 for bedroom, 9.6 for study room. Then 9.7 for hall, 9.7 for kitchen, 9.7 for study room, 9.7 for bedroom. Then 9.8. Okay, so then 9.16. So you can see, even though I have sent data in between this interval, all my data are grouped according to the timestamp to 1 minute. Okay, so this is basically a simple data processing which we are doing in real time. Okay, so now I'm reading, we are doing it from the beginning, right? So let's just change the code from earliest to latest. Change the code from earliest to latest. Okay, so then let's just run the cell. Okay, then let's open the Kafka producer, which we have here in the code. Okay, so basically this is my Kafka producer code. Okay, so you can see all the details. I have my client properties and everything. Okay, so let's just start the program. So here basically I have just set the time.sleep to 10 10 seconds. So let me just change it to 2 seconds maybe. Okay, so every 2 seconds I'm going to send the data in the key hall, kitchen, bedroom, and study room. And our aggregation logic, let's change it to 5 seconds. Okay, because just for the sake of video, we cannot wait for 1 minute for the aggregation, right? So let me just change it to 5 seconds. Let's change it to 5 seconds. Okay, so a minute, I'm going to change it to second. So let's just copy this. Let's just change it to 5 seconds. Okay, so now let's start the data publish here. So basically you can see we are using a Confluent Kafka producer sample code, and let me run it. So once I run it, you can see the data started sending to the Kafka broker already, and you see every 1 minute, every 1 second, we are sending the temperature data. Okay, so let's open the terminal. So you can see here the temperature data being sent. So let's open the Confluent code and let me execute it. So let's run the cell, and you can see the command is running. So let's wait for a while until the cluster starts. Okay, the stream is initializing. Okay, the Spark jobs are started. Okay, so we are aggregating it to 5 seconds. So as you see here, so we can see the data being aggregated to every 5 seconds now. So you can see the timestamp now it's 11:40 p.m. and here it is showing 3:40, which is basically the UTC time. So you can see 11:40, 10, 11:45, 11:39, 55, 11:40. So let's arrange it in order so you can easily see 39, 55, 40, 40, 45. Okay, so everything is already being aggregated to 5 seconds. Amazing, right? So we are basically doing a real-time streaming and real-time processing. So this is really the beauty of data engineering, and you can do really a lot of cool things with this kind of functionalities. Okay, so now let's just stop the cluster and let's insert the data into a database instead of showing it in the terminal. So let's just run this cell. So as you see here, guys, the operation is started and the data is being inserted into the database every 5 seconds according to our logic. So here I have opened my Postgres pgadmin, and you can see my list of tables and database here. Okay, so you can see the schema. So let me just try to, so IoT telemetry is my table. I'm going to execute the query. Select everything from public.iot telemetry, limit 100, order by timestamp in descending, just to show you guys the real-time data. Okay, so let me execute this. Okay, So I think order by should come first and limit 100. I should put it last. Okay. Okay, so you can see here the timestamp is 15:57, which is just now 11:58. So if you wait for 5 seconds, so you can see here the data will be grouped every 5 seconds. So you can see when I refresh, I can see the data being grouped. Okay, sorry, I think there is a small mistake here. I hope none of you guys noticed here. So data is being inserted 2 seconds because we are inserting val df here. So by right, I should be inserting the tumbling window df, and that's there. Okay, so now this will now this will insert the data every 5 seconds. Okay, sorry for this little bit of confusion. So now we have started the streaming again, and let's just wait for the process to be started, and we can keep checking the database. So I can execute it again. So you can see here 15:58:27, and let's check. Okay, average temperature not found in schema. Okay, so I think the problem is with the column name. So here we have put average temperature, but here the column name available is temperature. So I have edited this code a little bit here. So just by adding one more line, so I have renamed the column name average temperature as temperature here. That's all. Okay, so then I'm inserting the temperature into the database every 5 seconds. So let's just execute this. So you can see here, see the time difference is 23. So as you see here, 16:1. Okay, so you can see all the data 1, 2, 3, 4, 5. So every 20 seconds. So here it's 25, here it's 35, okay, here it's 15. Okay, so now when you keep executing, so you can see the value being inserted for every 5 seconds. So you can see here 30, 35, 40, 45, 50, 55. Okay, so basically that's the idea of this aggregation, real-time data streaming, and real-time data processing. Okay, I hope you guys have got a good understanding of how this IoT real-time streaming is working, and how you can use this setup in your own code. Okay, or your own to create your own application. Thanks for watching, guys. Let's make technology easy peasy for everyone. In case if you have missed to subscribe to my channel, please do subscribe and support me. Okay, so I'll see you with more interesting contents on IoT, cloud, and open source softwares. Okay, thank you very much.